So 15. How'd they go? How are you feeling about these? Yeah? Yeah, pretty good. We need to go over it?
Yeah, we should. That's okay.
I think we should.
All right. 15 and 16?
Back to the
You didn't agree with the back of the book? Or you
No, I
did?
did.
Oh, that's a good sign. Most of the time, that's a good sign.
I didn't even look at the back.
Nick, how are you?
Well, you can
Good.
look
Good.
in this one, check.
Did you do like the first set now of homework?
No,
Because I already have your 15 and 16 set.
I did that one again because I know I got the current.
Going back,
I mean, I guess.
saving them for you.
Yeah.
All right. We'll do them. It's good prep for Friday.
How long do you think it's gonna take?
I don't know, it was 8 problems last year. That was like,
I think you should.
I was
like,
mean
maybe,
last
like,
year.
2 problems.
there's 7, 2 puts a lot of stress. That's a lot of stress on 2 problems.
50 real quick.
That's like 50 points each.
But if you just
You want
make
a
them, like,
50-point problem? What if you screw it up?
just make them like the last quiz.
I want to make them challenging for you so you feel good after you walk in.
I don't think.
Feel good. I'm just gonna.
No.
About that,
It's
but
like,
I hate
like,
it when I
stress.
quiz.
Like if you're gonna go for a run, you don't want to go for a 3-mile run. You want to go for like a 10-mile run to feel good about it. Not a great, you know? All right, I'll work on my
Take the name.
analogies. Make what?
The name half the point. You can
Yeah,
write
like-
it down.
Okay, there's a free body diagram problem. That's like a free 20 points.
Okay.
I'm looking at 5 problems.
5 problems?
Yeah.
Okay.
So that should take like 30 minutes.
30 minutes.
If I like struggle. Right?
If you struggle.
Okay, so 5 problems are gonna take me 30 minutes to do.
Okay, so
So I
maybe-
usually multiply times 3, hour and a half.
Oh, gosh.
Did you say if you have any, like review problems with the?
We're doing them right now. Like everything we do today will be review problems, because after this, after we do homework sets, I'm just gonna review. Then we'll look at the homework set for Friday and work it probably, or at least start it for you, so. So you have a good vibe going into Friday. Am I doing the right one?
Yeah.
Oh, good. I don't wanna pull a Nick. Oh, how many reactions for a pin? I was just putting them in automatically. 2. I'm gonna make a guess at up. Everything's coming down, so we need some up forces, right? How many reactions at B?
Just one up.
Just 1 up, it's a roller. So that would be BY, AY, and AX. 5K. You can see this, right? Yep. 14K. And 6K. 3 feet, 7 feet, 6 feet, 4 feet. On Friday, it will say you do not have to draw separate free body diagrams on the problems. You can just kind of turn the problem into a free body diagram by putting your reactions right over the top of the supports. Unless the problem says, draw a free body diagram. So then you should do that. That make sense?
Yeah.
So on the longer problems, you don't have to make additional drawings. All right. This one wants to know what?
Exactly the reactions.
Calculate the reactions at each support. So we would need I would need 3 things on Friday, 3 reactions, even though one of them is equal to 0. Yeah, I still want all 3. So even though you know AX is equal to 0, you know, give it to me. AX is equal to 0. You can show me the equation if you want. If you don't, that's fine. I'll just know that you know, hey, if there's a single force in a direction, it's equal to 0. All right, so then we need AY and BY. What are our 3 equations of equilibrium? What are the 3 equations? F of X equals 0. F of Y equals 0. And all the moments equals 0. Okay, so that is the definition of equilibrium. And that's the three tools we use for these. What kind of a force system is this? Is it concurrent or non-concurrent? Non-concurrent, because
No, they don't go through the same.
yeah, all the forces don't go through one spot. Yep. Excellent. These kind of problems use all three. Okay. Concurrent force systems, ones that look like this. Those don't use moments. There's no moment here, right? Because everything goes through one spot. So these just use some forces in the X and some forces in the Y. That's it. Okay, all right. So how are we gonna solve this? What's the plan here?
They know.
We're gonna use these, which one?
F, Y, and F.
Right now, all four.
You can write them all out, but are we gonna use this? No, that's out. We already did to get that, right? What about this? We're gonna use it, or can we solve anything with it right now?
No.
Why not?
Because you have two unknowns.
Because there's two unknowns in the Y. Right? We could write it out. That's easy enough. And if you don't know what to do, just apply the equations, just write them out. Right? Some forces in the Y. What are all the forces in the Y? Plus AY minus 5K minus 14K
6 gives.
minus 6K plus BY equal 0. On Friday, if you don't know what to do and it is a equilibrium problem, find the reactions, apply these equations, just apply, write them out, and you'll get some.
This is.
Yeah, so this is when it says find the reactions, that's an equilibrium problem. If it says find the resultant, we're gonna have to remember what the hell that means, because that's what we did for the first 4 weeks, right? This is week 5. So you're gonna get so locked into this. I'm gonna give you a problem on Friday that says find the resultant. And what are you gonna do? You're gonna draw me a free body diagram, and I'm gonna go, don't do that. Don't draw a free body diagram. We didn't do this for the first 4 weeks. We didn't put these reactions in. Right? We just ignored them and did resultants. Well, like half the exam is resultants, and it really should be more because the first 4 weeks was resultants. Only the last week has been this.
So there's more results.
There's definitely, well, no, it's half and, well, 5, so gotta be imbalanced somehow. Okay. So that's really important. You're gonna lock into that, like read it carefully and know your path. Because this is find the reactions. Right? Not find the result. All right. 2 unknowns, we can't solve it. Correct? Correct. All right. What do we have left? Yeah, moments. Most of these kind of problems, you're just gonna apply a moment right away to solve for something. Like I just start doing moments typically right away to get my unknowns. And then I might go back to summing forces in the Y. But you literally could go and sum a moment here, right? And what would be the unknown if I summed the moment at this spot? BY. So I could solve for BY, right? And then I could do a moment here. And what would be the unknown? AX goes through the point, it would drop out. And we could solve for AY. So you could do 2 moments and solve the problem. You could also do a moment and then do this equation to solve the problem. So there's a couple paths that you can take. All right, where do you want to do the moment?
A.
Why do we like A?
Either way, it'd be the same. Just go
Yeah.
with A.
It will be.
That's what I did.
Either way, because we read left to right, so we always go to the left side. I mean, I do it all the time, right? But yeah, either spot is the same. Because at B, there's 2 things that drop out if I do a moment here. What are the 2 things if I did it here? AX and BY drop out of the moment equation because they go straight through the point. If we do it here, what drops out? AX and AY both drop out. They go straight through the point. Okay? All right, so let's do it today. What are, after you decide where you're doing it, you just need to collect all the moments, everything that creates moment. Does the 5? Absolutely. 5K times what? 3 feet. What about the 14? What's the rotation of this? Don't let me forget that.
Yeah.
Is it going clockwise? Does the clock tick this way? It does. It's clockwise, it's negative. Tell you, a crib sheet, a cheat sheet, whatever you want to call it, is more valuable than your book. You think it's awesome that you get your book? Well, it's 250 pages of trying to find something, right? But if you had a crib sheet with just notes on there to organize everything for the test, it's way more efficient. Way more efficient. I used to give extra credit for a good crib sheet. That'd be cool. Should we do that again?
Yeah.
How many points?
1,500.
Well.
15 towards the exam, like you could, how about 20, and you can just eliminate one of the problems, you can toss it out,
How many
that'd be
points
sweet.
is the test?
How about, oof,
Is it
I don't know, it's 100 points, yeah,
It is?
yeah.
Okay, so actually, that's fair.
Just turning your crib sheet and walk out,
Yeah.
man,
Really.
that's a
Good choice.
great negotiation. Now I'm feeling pretty good about my 2 points that I want to give you. All right. 2 points, extra credit.
All right.
If you have a nice, it's gotta be a good crib sheet. Okay, it's gotta like, chapters 1 through 4 gotta be included somehow. Does that sound fair?
Sure, yeah.
All right, sweet. All right, 14 times what? 10. Yep. Rotation. Negative. 6 times 16. Rotation. Negative. What else creates moment about here? By times 20 and its rotation. Positive. Set it equal to 0. You now have an algebra problem. Remember, this just goes away. Oh yeah, so your numbers are different too. Yeah, so it's 6 times 4, it's 14. If we're doing it at B, right? 6 times 4, 14 times 10, 5 times 17, AY times 20. Yeah? And then the rotations flip if you did it at the other side. The solution, exactly the same if you've done it right. That means you could do like both sides and just check your work. All right, what do we get for BY? Somebody's got BY. 12.55 kips. Anybody else get that?
Yep.
Yep, thumbs up. And it came out positive. Yeah, and that means
Our assumption is correct.
our assumption of direction is correct. So that'll trip up somebody on Friday. So be careful with that. If BY was pointing down and it comes out positive, that means you've made the correct assumption. It points down. We made the assumption it points up. We did the math, it came out positive. That means our assumption is correct in direction. Okay? All right, that means this is up. So on Friday, the problem could say calculate the reaction at BY, and then it could give you some information about that roller. Like the roller at BY can support 15K. Determine if this is safe, right? So that would mean, well, we got a limit of 15K. We do the math, we figure out that we're 12.55K at BY, we're good, right? So sometimes I try to make it a little more real than just an academic problem. Like, Why would we be doing this? Well, we might be looking at this roller, determine if the load's okay on there. All right. How do we get AY? Plug it into the Y equation? Yeah. So we take AY up here, 12.55K. Going up. Let me calculate BY. Oops. BY, sorry. I got reversed. And we calculate AY. Right? What'd you get for AY? 12.45? Anybody else get that? Not that I don't believe Gina. But I believe Gina. So there they are, 1, 2, 3, right? Find the reactions. Easiest problem because everything's parallel, right? If we had an angled force in here, how would you deal with that? Yeah, you just break it into its components and know that the X component would not create moment anywhere. And you would deal with that Y component for the moment piece. Okay. So we've done some of those too. They're not difficult. Problems are not difficult on Friday. They're of the simpler kind of problem. So if you have a resultant problem, it's not going to be a super hard one. Find the reaction problem.
It'll be kind of similar to the ones that we had in quiz.
Yeah. Yeah. Yep. Now, it might look like you're going to have to determine if it's a concurrent or a non-concurrent. Like it might not be straightforward. You might end up with a beam that looks like this, right? Has a roller, has a pin, and then has a force, and a force. Right? If it says find the resultant means don't mess with these, leave them there. We just want to know where what the single force is of this thing. Yeah. Is it a concurrent or non-concurrent? Yeah, it's concurrent. It's all right there. Even though I put it on a beam, it's still all the forces are in one spot. Right? We would turn all this into some resultant single force. So just identify the force system and identify what it's asking you, and then have a strategy ready to rock, and you'll be good to go. All right, 16 had some distributions. Same problem, find the reactions. Have a distribution that goes more than halfway. And then a smaller distribution. There might be a little off scale there. What do we do with these distributions?
Concentrate them.
Concentrate them. Love it. $16 and $10. So this is a find the reactions. So what's our goal here? What do we want to know when it says find the reactions? Okay, I'm still looking for what do we want to know? That's what we're going to do. What are we trying to learn when it says find the reactions?
Find
The reactions at the points.
What are they called? They're not called points. Supports. Yeah, we want to find out what's going on at the supports. What are the supports on this problem? The pin on the roller, yeah. Assuming that's a pin or a knife edge, either one, hard to tell. They didn't tell us, did they? They just said find the reactions, so. A pin gets how many?
Two.
2? Which way do you think they go?
Up.
up and somewhere. Not a lot of X forces going on. AY, AX. So because it says find the reactions, these are the reactions, we gotta put them in to find them. And a roller gets one vertically upward, BY. We got 2 kips per foot. And we have 1 kip per foot. All right, how do we concentrate? We think really hard, right? Area of the distribution. Yeah,
So the way it's drawn, I don't know if this is gonna make a difference, but the 1 kip foot is across the entire beam.
oh, that's
That-
important.
That
Sure it is.
That's how I understood it.
No, I don't think,
like the force. I
yeah,
mean, we're-
that's an assumption. This is an assumption you would want to make. So what is it? Is this 2? So that's
Yeah.
one assumption is that's 2, making the total height what? 3. Right? Or the assumption is this is 2. Yeah, so it's tough. Like I
It's got
get,
different arrows.
especially because they drew it all the way across.
It's supposed to be the weight of
Oh, this is the way to the beam?
the. That's what we were debating.
Ah, so there we go. That
Well, it
solves the
includes
problem.
It includes the weight.
It says the 1 kip includes the weight of the beam.
So it's the 1
That's-
kip.
That's
The weight of the
true. Yeah, it's a really poorly worded problem. But good in that you have to make an assumption. If you note this assumption, you're not gonna get it wrong from me. This is a fair assumption either way, whether this is 2 to the top or whether this is 3 to the top. Right? So now that it says something about the weight of the beam and includes the weight of the beam, I would say these are cumulative. Because if you had the weight of the beam and then you had a 2 kip foot distribution, you'd have to add those 2 together to get a total of 3 on certain part of the beam, right? So that would be the way I would assume it. Because it says this 1 kip per foot includes the weight of the beam. That means that this is, the 2 kips per foot is external load of some kind, and this is some kind of an internal. Could be the beam and then the platform and then, you know, the structural components that go across. That could be all of that structure, and then we're gonna put 2 kips on top. So if you didn't assume that, that's fine. You don't have to erase it. But I would say this is 3 up here. Making this 2, this including the weight of the beam, 1, 3 total in a certain region, so. That's the way we'll go with it. So the concentration for the 3 is 3 times 16, right? 32, 42, 48. Yeah? 48 for the concentration, is that right?
I mean.
Yeah. 48K.
We
Did
did.
it different?
Yeah.
Made the other assumption?
So 2 kip feet, 16 feet.
Yeah, that's
We
fine.
did
That's fine.
match the 1.
That's fine. I'm okay with that assumption. I think it's fair. I'm not making that assumption. So there you go. So that means we have 1 kip feet here at 10, which is 10K. I just should be a different color, maybe. Don't know if we have a different color. So we got 10K here and we have 48K concentrate. Yeah, this is 8 over. And then this is 5 over. Good. Concentrate it. And then go to work, right? Probably straight to a moment. Where'd you do your moment? Eight's a good spot. Everyone see where I'm getting the 48 and the 10?
Yeah.
Okay,
Yeah.
so moments about A, I'm gonna take the 48 K times 8 feet. And that rotation is negative. And I'm gonna take the 10K times, looks like it's 26 minus 5, 21 feet. And negative. We're doing it here, moment at A. 16 minus 5, 21. And then BY times the full 26. And its rotation is positive. So if you made this assumption, 3 kips per foot assumption, you end up with 22.85 K. So then I might sum forces in the Y to figure out AY. So AY goes up. 48 comes down. 10K comes down. And then 22.846 2K goes up. Just rattling off all the Y forces there. 48 down, 10 down, 22.8462 up. AY equals. Reactions solved for. Yo,
Our assumption was different, correct, but our answers came out the same.
You got?
you got BY 22
Yeah,
Yeah,
and you got AY 35.
yeah.
like exactly the same decimal.
This is the. Oh, I
How's
didn't
that
know.
possible? That's not possible.
You wanna see?
No, I don't want to see.
I did it the way that I think they did it, but I definitely couldn't do that.
Didn't get this.
No, because I did it the other way, but then I did it or whatever did it, but.
What's your concentrated loads?
32 at 8 feet, and then
26.
26, 13 feet from B.
That's how I did it.
How'd you get 26? What was the 26 for? Oh, the whole one, the whole distance.
Yeah,
Oh, so you're using the one kip twice.
Yeah. Okay, now it makes sense.
So that would make sense.
what? The one hit twice. Oh, I guess so, yeah, sure.
Yeah. That's doing it the same way. You just broke it into 2 shapes.
Yeah.
Yeah,
Okay.
yeah.
Well, like we didn't stack the 2K.
No, you didn't. You did them individually. You broke them into 2 shapes.
Yeah.
Exactly, perfectly fine. Yeah, that's fun. You guys are like, what? How's this happening? Yeah, I was too for a second. Oh, I get it. Which is actually a really good point, right? You can take the distributions and break them up however you want. So I don't know if the rest of you are tracking that, but Juan and Sean, that's kind of funny, rhymes, used this bottom distribution, concentrated it, and then the top distribution and concentrated it. So those are just different concentrations than I did. I did this, right? And then this. Doesn't matter how you break up the distribution, you'll get the same number. And they got the same number we did. They just used two different shapes. It's fine, especially when your shapes get really complicated. Like, if we get a shape that looks like this, maybe doesn't have this. Right? It's two complicated shapes. You don't want to deal with this as one shape, even though it's drawn like this. Some kind of load coming down. You want to break it into rectangle and a parabolic curve. Excellent.
Does parabolic curves on that or? Triangles?
We have it. Yeah, just triangles. It'd be pretty evil for me to give you a parabolic.
That's what I was thinking.
It is in the front of the book, and you are fully capable of calculating these areas. I know you are. Right? You can do that. 1/3 the base times the height. And then the location would be b over 4 and pi over 10 times h. You're capable of that, but I'm not giving it to you. We haven't practiced it yet. There's always exam 2 in the final, you know, for me to stack things on. No, you don't think?
I think
You're gonna feel good if I do. If I give it to you, you're gonna feel good about it. You don't- All right, turn them in. That's 15, 16, and we already did 17. 23, 24, and 26 is your homework, so we're gonna look at those next. You need a break?
What?
Let's take a 5-minute break. You know, coffee is going well and whoops. All right, we'll get 24 captured. Sorry about that.
Which one is this?
This was 23.
That was 23, yeah. Here's 24.
Are we gonna get, extra credit for that?
Wait, what did that one say?
What extra credit would you want for that? I don't know. I'm confused.
Extra
You're just making shit up
on
now.
top of.
Yeah.
Many credit as possible.
I'm gonna start cussing. Number 24, we got 120 pounds. We got 800
26. We just did
in the center, 800 in the center. And then we got 400 at some crazy angle. Feet. 8 feet. 7 feet. And 3 feet.
I have the book open. What are the units for the forces?
They are
Pounds.
pounds. A. B. Four.
Also, I know you answered this before. Normally I don't use the arrow, up or down. I just use that sign. But you would understand the answer, right? So-
Yeah, I'll go by signs for sure. Yep. So that means if you leave the negative off, I'm gonna assume you meant it positive, and yeah, so just be careful with that. But yeah, absolutely.
Yeah, because I'm not used to write that.
No, it's fine. Yeah. This one says Determine the reactions for the beam shown. The beam has a pin support at one end and a roller support at the other. Neglect the weight of the beam. Reactions. Step 1, free body diagram. Step 2, concentrate any distributions. We don't have any. Step 3, apply the equations. So free body diagram first. Let's do it right on top of the existing drawing. Is AX equal to 0? No, is not. So don't just do that automatically. There is X force. What's AX equal to? The component of the 400. Those are the only two X forces, right? So I put AX to the left, is that correct? Yes, because the X component of the 400 goes to the right. And they've got to be equal and opposite. For equilibrium to be true, summing the forces in the X has to be equal to 0. So that's a good place to start. Now, how you do this is up to you. You can draw those little components in. You can just go straight to the equation, whatever is comfortable for you. I tend to draw them in. So, X of the 400 and Y of the 400 is the notation I use. Because there could be other X and Y's and you're gonna have to keep them straight if that's true. And then I just put the equation in the formula. Sometimes I pull the 400 off to the side just to make it a little more clear. And then put in the X and the Y and my angle of 60 degrees. Transfer this over, make my triangle X, Y. So if that helps you, do that, right? Because then you can write the equation for the X component, which is going to go in this, right? It's adjacent, so it's cosine 60 equals the X over the hypotenuse, which is 400. Right? And it's this X component that I want in this equation. So then I could solve for that. X 400 equals, you can come up with a number or you can write the equation, whatever is comfortable. Cosine 60. That's just a number, right? This is just a number. So I can calculate that number and put it in the equation, or I can put this in the equation. Either one.
For future reference, guys, when you have a 60 or 30 degrees, the opposite or adjacent bending would be half of the amount of the hypotenuse automatically.
Okay, no shortcuts. It's my philosophy. I always write it out. Never try to memorize that crud. I only have so many memory cells. I got other stuff more important. I got to remember my kid's name. More important than the cosine of 60. And birthdays and wife birthdays and wife Valentine's Day. Is that coming up? Yeah, you gotta remember that crap.
Anniversary.
Let me tell you, it's important stuff. Anniversary is easy. That's,
An alarm.
put an alarm on your phone.
Yeah.
Yeah, I lost my phone like during Christmas break. It just died. I didn't lose it. It died. I lost everything in it.
Do you remember your?
Really?
Yeah. Everything. They couldn't get any data out of it whatsoever. That was disturbing.
Got some notes. I have a terrible memory.
Well, you gotta back it up, and I thought it was automatically backing everything up to the cloud somewhere. Not like your notes and your apps and all that crap. No. Not even my contacts. I lost everything. I know, I didn't think that was even possible. And it's because I didn't have like a Samsung
I
account.
actually do, I am supposed to.
Oh, your
wrote it down.
Samsung.
Yeah,
Does
an
that-
Android, you have to have an Android account for it to automatically back everything up. And I never went on to Samsung and made an account. I got one now. Cause like, it's free, there's no reason not to do it. It was dumb not to do it, but
I got locked out.
I didn't know.
Not all of it,
Yeah.
just 320.
Wait, when you find the Y component and it's positive, because.
Whoa, wait a second. Let's not do Y yet, I'm doing X. I'm doing X. So I'm gonna finish my X equation here. So what goes in to my X equation?
You could just. Y or X 400 or.
So this goes in, right? My X component goes into the X equation, correct? Yeah, is it positive or negative? It's definitely positive, and I'm just gonna write this in. You could use a number, because it is just a number. Right, but that is the X component of the 400. And I am doing some forces in the X. What other force do I have in the X? AX. There's only two of them, correct? There's the component and there is AX, that. So that means, and it's all equal to 0, AX equals cosine 60 times 400. Jorge says that 60 cosine is a half. He is so correct. And that's equal to 2.
So basically should just be, are you just checking your answer at this point, basically?
No, that's my answer. It comes out positive, so that means the assumption is correct. AX points to the left.
Does that work? Like when you make the assumption and you're assuming that it goes in the direction,
Yep.
it's always in positive.
No.
Even though it's going in the negative direction,
Yeah.
it's coming in positive.
Yeah, if it comes out positive, that just means your assumption is correct. It's going in the negative direction. Yeah. That's confusing for people, I know, so try to sort that out. The number from the equation comes out positive. Right? That means your assumption of direction is correct, that it does point to the left. Okay?
Wait, so 200 pounds is pulling
AX equals 200 pounds
that way.
that way. Has to be, because this one is pointing
Oh.
that way. It's
Equilibrium.
gotta be equilibrium, equal and opposite. This equation has to equal 0.
You look at it, it looks like the only arrow pointing would be pulling away, but if it's an equilibrium, you would need that fully opposite.
This is the reaction, reacting to that load. Yep.
Oh,
Yep, if I push on you, you'll push me back, kind of thing, right? Or somebody's gonna fall over. Yep. Excellent. Those couple light bulbs just went on, I think. They're dim light bulbs. We're gonna up that wattage at some point. All right, so what do I do next? My gosh. Yeah, let's go to moment, because if we sum forces in the Y, we're gonna end up with 2 unknowns. So let's go for a moment. Where do you want to do the moment at? Yeah, sum moment at A. All right, what are all the moments about point A? We're good at this. Part 120 times 2 rotation.
Yeah.
Negative. Yep, clockwise negative. Rotating like this. Don't forget your moments or rotation for the sine, 800 times.
Clockwise rotation. Negative.
Yep, same rotation, negative. All right, now we have this 400 thing. We want to use what? Yeah, we want to use this y force because the x goes straight through the point. So we do not need a moment for the x. It drops out, but we need a moment for the y force. So we need the y force. And yeah, that's going to be sine 60 times 400. And I'm going to write it in just like that. Is it clockwise or counterclockwise?
But when the answer comes out like positive, it's.
Hang on 1 second. Sine 60 times 400, that's the force. Agreed? We have to multiply the force times the distance. We're doing moments. So it's force times distance. How far is it from here to here? 17 feet. All right, Gina, question.
I was just saying that when you do like the sine 60 times 100, it's like a positive number, so then, but it's still just there.
Yeah, so that's just the magnitude of the force. When you're doing, yeah, it is, because when you're doing moments, you just think about rotation, and we're doing moments. Right? Not whether the force points up or down. We don't care. We care about rotation when you're doing moments. So this is a part that is easily missed. This is the force. That's the distance. When you're doing moments, it's force times distance, force times distance, force times distance. Okay? And all of that, we have one more, right? We got that one, that one, that one, but we need our unknown. By times, we're running out of space, times 20, and that is positive. And then all of that is equal to 0. So again, we need our algebra skills. By times 20 is positive. We're going to leave it there. We're going to move everything else to the other side, which changes its sign. So negative, negative, negative becomes positive, positive, positive.
By the 20.
Absolutely. Got to get by by itself. Check my number.
Item 411.26. So what you got?
I got
Whoa,
294.45.
Oh, but. you
I
got
did
that.
not.
You did not. Okay, I'll do it again.
Got 76.
Shoot,
I love it, everybody.
I got 441. Is that?
Yeah. Really good.
Oh my goodness.
The engineering firm just collapsed.
Back when we got to 36.
You got 706?
Yeah.
I got 706.
0.45.
0.4, yeah.
I got not 706.
What you got?
I got 694.
I also got. Okay,
Well, I got
582.
All right, so now because there's that kind of confusion, I'm going to break it down. So I'm going to go 120 times 2. So I'm going to go 240. And that's going to become positive, right? Because it moves over. This becomes positive. That one's pretty easy. 8,000. Yeah?
Yeah.
And then sine 60 times 400 times 17
Oh, 7.
is 588.927.
With sine 60 times.
Sine 60, 400 times 17. Don't forget the 17. Don't forget the 17.
Oh, you were forgetting that?
And
Yeah,
all of
I
that
got
divided by
my-
20. I'm still getting 294.44. My first number. Don't think so. What are you, you're not getting this? You're not getting 5888
I'm getting 706.
Same.
for the sine 60 times
Okay,
400?
let me tell you what I put in, 240 plus 8,000.
What are you getting for the sine of 60?
Sine of 60, I'm putting in sine of 60.
What are you getting for it?
Sine of 60 would come out to 3, square root of 3 over 2.
What's the number?
That's the value of sine of 60, but
0.866.
I'm not putting like a decimal, I'm putting sine of 60.
Okay. We have to break it into pieces to figure out the problem, folks.
Just type that equation again, because I don't, like,
So-
does that even make sense?
Do you want me to show you my calculator?
No, I'd like you to calculate this number for me.
Sine.
Sine of 60.
Times 400
400.
times 17.
588.
Thank
Yeah.
you. That's
Yeah,
this
but don't
number.
put
Wait,
that-
wait, wait, wait. That's this number, correct?
Yeah,
Okay, that's all. That's all I needed. What's 800 times 10?
8,000,
Thank you. And
Yeah.
what's this?
240.
Thank you. And then what's all this added together?
14128, yeah.
Yeah, one,
Point,
and then-
972.
divide that by 20 and it's
Okay, divide by
not
half,
two
20.
days.
Yeah.
706.1144.
It's for sure. So.
Okay, it's 709.
No, it's so.
Ah.
Oh,
Okay, so.
All right.
Oh, I didn't
damn,
store the
man.
numbers.
706?
706.45.
4.5.
I love it.
Thank you, Troy.
Equation's good.
I was all confused.
No, you weren't.
Actually, the first time I got the wrong number and then
This is the goal right here. Hopefully we can do the algebra. But this is the goal.
Oh, man, that was good.
That was good. I loved it. What do we have left? Yeah, why? I'll let you calculate that. I don't want to make a mistake. What do we get?
559.
Phew, I was stressed out, man. 550.97 pounds. Comes out positive? Yep, so it goes up. Meaning our direction is correct.
So you just. Moved all that to the other side, right?
Yeah, I set it equal to 0. Left,
Negative 706.
left this alone, made this negative, this positive, positive, positive. Yep.
I got five page.
Well, you must have rounded. Look at the number, 559.97.
Okay.
Yeah.
Yeah.
Yeah, it's a rounding. I'll ding you on Friday, so, you know, it's rough to ace a problem and then round it correctly.
Right, but that's story line.
That is 96, not 97.
For a second.
I used to 4 places here.
Oh, you
No,
have two places there, but then I stored the 3.
Yeah, yeah. Samuel, you're frowning. I'm just saying, you're frowning.
Got like 559.96.
That's what I got.
Oh, that's right. I just rounded it, right, to 97. So I got,
I think there's one.
oh, you're right. I thought that was a 7. I can't see it.
I assumed my calculator said.
It's a
7.
1. Yeah, you're right. That's 6. Boom. All right. There's 26. I want to leave enough time to review resultants because that's half the exam. Stuff we're doing right now is half the exam and resultants is half. So we can do 26.
26 is the problem.
It is a truss.
I would never trust on the.
Sure, absolutely. Are you going to solve the truss? No, you're going to solve for the reactions, which is what we're doing. You could have a building on the exam, right? You're not going to solve for the building components, you're going to solve for the reactions of the building. You could have a truss, you could have pretty much any structure. It looks complicated, but it's really just a structure. I'm not even gonna draw all those internal parts in because we don't need it. Like, we're not solving the truss componentry. We're just solving for that and that. That's all we're doing. The reactions. We will get to trusses, that's chapter 4. It's not an easy one because it has all these angled forces. Those are all pounds. And we're 6 feet here. And each one of these sections is 8 feet, so my scale's a little off. And these are at 50 degrees. This is A. This is B. And it says find the reactions. Correct? Calculate the wall reactions for the cantilever truss. The upper support is pin, the lower is a roller, neglect the weight of the truss. Same problem, find the reactions. What was step 1? Rebody diagram.
Draw a line and just transfer everything to same line.
Don't get ahead of the steps. Do the steps in order.
Well, for the free body diagram, you wouldn't wanna do just along.
No, you want to put them where the reaction is, because those reactions are at those supports.
Because I was thinking. That doesn't apply here.
No, well, it doesn't apply, but not for the reactions. The reactions are at a specific spot. The roller's at B and the pin's at A. So that's where the reactions gotta go. Right? So we remove the roller, we remove the wall, and we put the reaction in. The reaction from a roller is always perpendicular to the surface removed. So the wall was the surface, we remove it. The roller is perpendicular to the wall. So the roller reaction is here. Which way does it go? Yeah, you have to think about like, oh, well, roller can only push on something. It doesn't pull, so it's got to point to the object. Again, it's not going to matter that you mess up a direction. The math will fix it for you. And that should be labeled BX because it's in the X direction. How many does a pin get? 2. So there's one here. And there's one here. And then that pin is gone. That roller is gone. Which way do you think they go? A, X, and A, Y. Yeah, so let's make that assumption that a X goes in and a Y goes up. It's a guess, we're not sure. There's a lot of forces going on out there. There's the 200, there's all these X components, there's a lot going on. So I really don't know which way AX goes. So I'm guessing. So that's step 1, free body diagram. Step 2 was concentrate any distributions. Do we have any distributions? No. Step 3, apply the equations. So let's just do them in order. Some forces in the X. What are all my forces in the X? Plus AX plus BX, I heard the 200 minus 200, right? I picked off the easy ones so far. BX, AX, yeah, we need these 2 components. So they are adjacent to the 50 degrees, so that's going to be cosine 50 times 500 and cosine 50 times 400. And those are going which way? Yeah, both of those components point positive. Any other X forces? No. I don't see any other. We set that equal to 0. And we try to do algebra, but we don't because there's 2 unknowns. So we picked off those components without drawing any extra pictures. If you need to draw extra pictures, do that, right? We're summing forces, so we don't have to worry about distances, right? We're just summing up the forces. We only do distances when we're doing moments. 2 unknowns, can we do anything with this equation? Not really. It's nice that we wrote it. You'll get credit for writing them, even if you don't use them. That's a good thing. So again, if you don't know what to do, apply the equations. What's the next equation?
Y.
Yeah, some forces in the Y. What are all the Y forces? Plus AY. Pick off the easy ones. Yeah, so we have these components coming down, so we can write sine.
Sine 50. 500. Sine 54.
And those are coming down.
Yes.
Picked off all the Y forces. How many unknown? We have one unknown. So we can use this equation to solve for one of our solutions. All the signs change as we move them to the other side. Grab my number twice to make sure I got the same number, so that's good. Should do that on the exam, you will have time to do that, so. Run your equations a few times, make sure you get the same number both times. Came out positive, so AY does go up. Got one of our answers. How are we gonna get AX and BX?
If BX.
Gotta go for moment. Third equation. So we did the first equation, did the second equation. Now we do the third. Sum a moment. Where do you want to do it? At A. Okay, I'm gonna pause and let you catch up. I don't want you to scramble too fast. I'm gonna turn the sound off, but that's better. Because the moments at A is, it's not complicated, you just have to do it carefully. You don't want to miss anything. And it's just force times distance, force times distance, force times distance, just over and over, just like we've done, but we have to, this is like a two-dimensional, three-dimensional thing, right? It's got height to it more than a beam, so it makes it a little more complicated. But if we're doing a moment at A, what drops out? That's always good to think about. Like, what does not contribute moment at A? AY, AX, both of those. The 200 goes right through it. It does not contribute to the moment. And these X components go right through it. So we drop a lot of things out doing a moment here. This one's gone, this one's gone, these components gone, 200 gone. Because they go through the point. What's not gone is this Y component, the 800, the 600, and the BX. All of that creates moment. So I'll pick off the easy ones. BX times 6 feet. The distance from A to the perpendicular to BX. 600 times this one, line of action is here. That distance from here to here is 8 feet. Rotations, I have to think about those. This looks like it's positive. This looks like it's negative. What about the 800? What's it times? Line of action is here. Perpendicular distance is here. 8, 8, and 8 is 24. Its rotation? Yeah, negative. Well, those are the easy ones, if you can see those distances. Now we need the components of the 500 and the components of the 400 in the Y. So, yeah, that's sine 50 times 500, that's what that is. Sine 50 times 400 is that one. So I can write, I'll go with 500 first. I'm gonna go down here and say sine 50 times 500. That's the force. That's this. Times the distance of 8 feet. Super easy to forget to multiply by the distance. So find the force, multiply by the distance if you're doing moments. That rotation looks to be negative. And then we have one more. And the distance for this one, 16. Yeah, it's getting real. Not a truss problem, just a truss structure that we're finding the reactions of the supports. The full truss problem will be next chapter, and then we will find all of those supports inside the truss. So the problem will start with this, and then you'll go inside the truss. Talk about a long problem. We'll get like one of those done in 2 hours. Good times. All right, somebody give me a number, BX. I'll come up with it. I did not. I'm gonna run it again though, before I commit, but don't forget the 8. Don't forget the 16. Yeah.
same thing?
I did. I'm pretty happy with my number.
You also get 2,500,000.
I did not get that.
Like,
Based on this number, I'm expecting something in the thousands, not millions.
how big it's-
Yeah. So I got 5,327.
Whoa,
Yeah.
I did not.
I got 5,532.
No,
No,
don't,
4,900.
don't forget to divide it by 6.
Yeah.
Divided by 6, I got 5327.81.
I divided by 6.
Divided by 6 too.
Yeah, divided by 6 too, and I think it's positive.
What'd you get? You were close though, right?
5532.
Oh, 5,5.
Yeah.
So walk through your equation with me.
I'm gonna. store
BX
the
times
signs.
6.
Yeah, and then 600 times 8.
Yep,
800 times 24.
yep,
Sine 50, 500 times 8.
yep.
And then sine 50 of 400 times 16.
It's perfect. And all your signs are negative except for the BX?
Yeah.
But our sign is negative.
And then.
Except for the BX, all my signs are negative.
Yeah.
Yeah, then they all become positive and additive. So it's a calculator.
I thought we moved to the other side, so we flipped this.
So that's good. What?
We moved to the other side, so we flipped this time.
Yeah.
Yeah.
I got.
I was
But
just saying-
I was going through, I'm going through the equation, which the equation should show
Sine.
sign, the
Oh, I
sign,
know you got, right?
negative, 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 negative.
Those are all supposed to be negative?
Yeah.
We flipped those.
When you do the algebra, I'm not writing the algebra. Look at, I have BX positive. That's a negative rotation. In the equation, it should be negative. To solve it, you're gonna move these to the other side and make them positive.
So they'll be positive when you enter in the equation,
Correct. Correct.
but you said they were.
We were walking
Negative.
through the equation together, so
Oh,
I wanted
gotcha.
to know what he had for rotations. Cause if you have all these positives in the equation, it's
It would
wrong.
Be negative.
Yeah, you would come up with a negative number. Yeah,
Okay.
yeah. Super good.
Got the same thing.
Yeah, so this equation's the important part, then hopefully we can all get the same number, but calculator problem.
Yeah.
Is your equation the same?
Yeah.
The parentheses that we-
Either.
It's the
either
brackets.
you
If
do it
it's a
all-
TI, it's
or you
brackets.
Put the parentheses where it's.
It's correct.
Oh, I did all separate.
Yeah.
You got it, Nick?
Yeah, but I don't do that, I just put.
I don't like doing it.
But
again.
figure the
Whatever.
brackets and the brackets.
Yeah, I just do it by chunks, 'cause I know I can miss parentheses.
And I have a really inexpensive calculator, $7.
Nice.
There you go.
I can't store anything though.
All right, we should talk about resultants. I know you're fried. Because there'll be resultants on the test, and that's chapter 1 through 3.
Is the recording?
Yeah. Yep. So this, I would never do this to you, but this problem could say find the resultant. Right? And that would mean don't put those in. And that you have to take all these forces and collect them in one spot. I wouldn't do that to you. So let's look at what I would.
So this is basically the homework, right, for Friday?
Yeah, you just did it. So now all you have to do is study for Friday. You can if it's appropriate.
I'm guessing because we have a test and the exam, we're not gonna have homework for the weekend, this time, right?
For you guys, I work, thank you.
For the weekend.
I would be there wrong.
Nope, I don't care. I'm done. I'm over it. Moving on.
I didn't realize my calculator could do brackets, brackets
Yes.
and parentheses separately.
The whole scientific calculator to do that. I don't remember how to do what.
I know, that's why we're doing it.
Think it's
Look at it.
It's
nice.
Yeah,
Right.
it helps to differentiate.
Yeah.
So I know what's-
Well, let's see what you.
I like reacting instead of.
Yeah. The cable at an angle,
Yep,
what's the angle?
okay. This is super important, though. Do you need it? If you're doing resultants, do you need the angle of the cable?
No.
No, it's a support. You ignore supports if you're doing resultants. So it would be evil for me to give you the angle, because then you tend to use it. I'll give it to you.
No, that's fine. that's
70
fine.
degrees. No, it's a good point, though. That's why I've put supports in that are weird. Because you gotta know the difference between resultants and reactions.
Wouldn't that be, that add up to 200 degrees instead of 180?
Oh, so it couldn't be 70?
It can't be said. That to be like.
Or this is not. Yeah, no, it could be.
Yeah, it can
What's
be
that?
70. It can be 70 because it's 180, so what you do 180.
Oh my God, you guys are gonna get sidetracked from what we're actually trying to learn. So I'm gonna pull that out.
Says
You don't
50.
know it. All right, there you go. You don't need it.
I know, we don't need it. That
That's the point.
angle right there, you can find it, it's just 180 minus 60
Don't-
and minus 70.
Let's focus on resultants, not
Let's
what
do
the
it.
angle is. All right, holy smokes. Love it. 1 meter, 6 meters from here to here, and 1 meter. All right. So the big difference is if it says find the resultant, what do we do with supports? You ignore them, just leave them. Don't touch them, don't put in reactions, or you're gonna be really confused. Okay, so if it says find the resultant, you're just taking external forces and combining them into one force. What kind of a force system is this one? Concurrent.
Which one are we doing first?
I don't know. I just wanted to show you both.
Oh, so we're not doing these?
No, we'll do them.
Oh,
Which one do you want to do first?
the beam.
You want to do the beam first?
Whoa.
So it's non-concurrent, right? Right? So two different problems. We're doing the beam first. And it says, find the resultant of the given force system. Okay? Find the resultant means leave the supports alone. We don't even know what those supports mean. For the first 4 weeks of this term, we had no idea. We just ignored them. Right? How many external forces are there? Dose. 2. 100 and 200. So our goal is to turn those into a single force and where it acts on the system, right? So how do we do that?
Moving, one of them.
Move them to some spot. You can move them anywhere. You can move them all to C. You'd have to move 2 forces, right? Keep it easy. Make it easy on yourself. Move them to A or move them to B, because then you only have to move 1 force.
Right.
So if I move them here, 100's already there. I don't have to move it, right? I just have to move the 200. Huh? You could move the 100 to here, or you could move the 200 to here. Either one. If you choose C, you got to move them both to C. It's more work, right? All right, let's move them to A. Sound good? All right, how do we do that?
Just come down.
You all right?
Yeah, but
Okay, good.
you can just.
So, we move both the translation and the rotation, right? The translation is 200 down, so I move it over. Remember this?
Yeah.
Yep. And then how do I get the moment over there? I just calculate the moment and bring it over. How much is the moment? 200 times
Times 7.
times 7, 1400. What's its rotation? and its unit is Newton meters. So now I have all the external forces collected at A. If there was 4 of them, you gotta move 3 to the 1, right? You just gotta get them all at one spot. So at A, here's my new point A. I have the translational effect of 300 newtons and the rotational effect of 1400 Newton meters. And there's my beam. Yep.
Yeah.
So what's the resultant? What's the magnitude of the resultant equal to? Don't let my words trick you.
300.
300, yeah, R equals 300. So that's a big part of the answer, because the question was, what's the resultant? Right? Now I just need to know where it is. Where is it at on the beam? How do we find that? Yep. So if you solve for distance, it's moment divided by the force. So this is the force, so the perpendicular distance is a nice x distance. That's nice. I know it moves to the right because I have to create this kind of rotation. So R being out here does create that right rotation. It's going to create that kind of rotation. So that's why I know it moves out there. And then this distance, 1400 divided by 300. .66 meters? Yep. Yep. So 4.66 meters right of A. That's the answer. We did not touch the pin. We did not touch the cable. Leave it alone. If you're finding the resultant, you're just working with the external forces. Remember that?
Yeah.
We did that a lot. Like we did it for a couple of solid weeks. All right, then there was this kind. Again, says find the resultant. So that means this force system, 10, 5, and 20 is what we're working with. And the cable, we just ignore it. Some cable. Okay. How did we do this kind? We have to collect all the forces at one spot, but that's already happened for us. So it's a concurrent system. We don't have to collect it at one spot. It is at one spot. So now how do we find the resultant?
Find the x components, find the y components.
That's right. Sum up all the x effect,
Like that.
sum up all the y effect, Pythagorean theorem, boom, you got R. So let's do it. Sum forces in the x is going to give me the resultant x component, which is going to be plus 10 and minus cosine 60 times 20. I have a lot of room, so I stacked them. It does not equal 0, not when you're doing resultants. It equals Rx, the x component, right? So don't toss in equals 0 because no, it doesn't. Rx equals 10 minus this number.
That equals 0.
It does, that's funny. That was random, you guys. I didn't mean for that to happen. But it does equal 0.
It does make zero as I hit enter.
Yeah.
Nothing.
Just don't write it in this equation, I guess. Prove it does equal 0. Wow, that was just bad luck. That's funny.
So it doesn't equal zero by default.
It does not. Resulting can definitely have an X component. This just is telling me now that, oh, the resultant is all in the Y, right?
The only reason it happens is because it goes like 60s.
Which we know, because Jorge taught us that.
By the way,
Or if you know your special. So,
Some forces in the Y. Hopefully that one doesn't equal 0, or we're really in trouble. It's gonna equal the resultant in the Y, which is gonna equal
20 sine 60.
-5 and sine 60 times 20, and that is positive. Phew, it's not equal to 0. Pythagorean?
Yeah. 'cause you're
No.
gonna square it, put it square
Like
it.
if you draw the picture, this is equal to 0, so. The resultant is all of this Y component. So I would just then write R equals 12.32 pounds. Up or down? Woo,
It's up.
it's up,
and positive.
because we got 5 down and then we got this larger,
Yeah,
like if- yeah, it came out positive. But be careful with
I
that.
forgot to times the sine 60 times 20.
So if you see a concurrent system, add up the X's, add up the Y's, find the resultant. If you see a non-concurrent system, move it all to one spot. Rock and roll. If the problem says find the component of a force, and you're given this, oh, where'd it go? Where's the big complicated one? Oh, I lose the truss already. Oh, there's the truss. Yeah, if you're given this, and it says find the X and Y component of the 400-pound force. Just do what it says. You don't complicate the problem, right? So you'll get a simple problem like that. You probably get a free body diagram. You'll get 5 problems.
Make input for AX.
On what?
That one,
Oh, this one, we didn't finish it?
no,
Oh, take this and
we didn't find the,
sub it back up to there.
I just told you use trivial.
yeah, I was gonna ask you, you care?
If it says find the reactions,
We didn't find,
you want all of them.
we did big class with you,
There you go.
this, for this specific assignment.
Oh, for the homework set. It's fine. I don't wanna overwork you, Sean. I don't wanna overwork you. All right, good job.
So the result